No questions? How are we practicing? Question, yeah. Heath?
Um, it's I'm just clarifying the derivative of these cosine sine of x's.
Yes.
So with the negative cosine of x equal, or the derivative of negative cosine x equal sine of x.
Uh, the original function is negative cos of x?
Yeah.
Yeah. So first of all, I got this alphabet wheel. A, B, C, D, E, F, G, right? N, Q, R, S, etc. And I'm going to move this way for my derivatives. So if y is cos of x, y prime is negative sine of x. So I'm moving past the negative when I go from cosine to sine. If I say y is sine of x, now I'm just going right to see y prime is cos of x. This is the other thing, is you want to let coefficients go for the ride. So if y equals 3 sine x, y prime is 3 cos x. The coefficient just goes for the ride. Okay? So if you started with negative cos of x, right, you would have the negative goes for the ride, and the derivative of sine is negative sine, so you would get just positive sine of x. That's what you said. Yep.
That's all.
Yep. So we should have, all our shortcuts on our formula sheet. Yes? That thing is going to be so packed with information, right? And you want to be building it, right? Like today, I'm going to put a couple of old questions on the quiz. So you want that formula sheet to grow, not just to be ready for the quiz. You want it just to be building and building until you're ready for the first test. I'm pretty sure the first test is going to be at the beginning of week 4. I don't absolutely know yet. I want to wait on Monday to make a final decision. But we will review an entire day and then take the test the next day. So any other questions for me? How are you practicing? What's the process? What are you doing? What's that? Good. Rewriting notes, rewriting the problems we do. Are you looking at old quizzes and old exams yet? You should be. Okay. So the chapter 2 test that's posted in our announcement, you can do that already. I would say give yourself 10 to 12 minutes a problem and actually take a test at home. Put yourself in the right frame of mind, right? On the test, you can listen to music, so feel free to do that as well. Set a timer. One of the things you want to be conscious of when you're taking the actual test is running out of time. So you've got to kind of say, all right, I have this particular set of music on. I know in 3 songs, it's about 10 minutes. And so if I'm listening now to the 4th song, I got to be careful if I'm still on that problem. If you're just staring at it blankly, move on, right? You want to treat math like you treat an English class, like a free write. So start writing, start thinking about what you can do, graph it, etc. Anything, right, to get an idea of what to do. All right, so let's talk about let's talk about L'Hopital's rule again, right? So let me remind you, and I asked you to do this, that if f of x is square root of x, right, we know f prime of x is what? One over 2 square roots of x. We should have that memorized. Of course, this is a power rule, right? This is x to the 1/2 power, right? So you can clearly see where the 1/2 is coming from, correct? And then why the square root moves downstairs, because I will end up creating a negative exponent, right? So I get 1/2 x to the 1/2 minus 1. So it's 1/2 x to the minus 1/2. That's 1 over 2 x to the 1/2, or 1 over 2 square roots of x, right? So we have that as a shortcut memorized, but of course we could do the power rule if we forget, yes? But I want to remind you, what if g of x is square root of x plus 3, right? What do we say about g prime? Same thing, how? 1 over 2 square root of, not square root of x. X plus 3. So the derivative is going to, I'll say, maintain the transformation, right? It's gonna behave just like the square root of x, but shift it over, right? In this case, shift it over left, right? So quick reminder, you remember me asking you to do that? Okay, so let's take a look at a L'Hopital problem. Let's look at the limit as x goes to 6 of the square root of x plus 3 minus 3 all over x minus 6. So our old days, and what your first question on your first exam is going to be, find this limit using a conjugate and find the limit using L'Hopital's. So do it twice. And of course, you're going to double check it numerically or graphically so you'll know you had the answer right. And then if you got one of those two methods wrong, you're going to just do it over, right? So let's do it with the conjugate first. I like to wrap multi-terms, even if I don't need to, just in case. But now I'm going to use my conjugate here over itself. Notice I'm just working on the function. I'm not writing the limit over and over, right? So, but I am really working on the limit as x goes to 6 of this function star. Trying to get that replacement function, right? What do I get? I get x plus 3 minus 9 all over x minus 6 times that conjugate. Well, that's kind of nice because it turns into x minus 6 upstairs, right? It better, or I'm in trouble. So that piece cancels. So I finally have my value of star, which is 1 over the conjugate. So I'm ready to plug in now, right? I'm looking at the limit as x goes to 6. Is everybody okay here? Of star, which is that conjugate, but evaluated at 6. So it looks like I get 1 over 6. Yes, question, Ethan.
Not that I don't know what the conjugate is, but I'm just not familiar with the actual term itself. What does the conjugate actually mean?
Yeah, so A plus B and A minus B are conjugates. We did them a while ago when we had something like x squared minus 4 and we had to factor it and we got x plus 2, x minus 2. You remember doing that? Yeah. So the key is what happens, right, when I distribute conjugates, right? So I get a squared minus b squared because the middle term, which is a positive ab and a negative ab, cancel each other out. There is no middle terms there, right? And so that's the trick I'm using, because notice what happens upstairs. There is no more radical, right? And that's why we're doing it. Yeah. Same problem now with L'Hopital's. So same problem, but with L'Hopital's. We're doing the limit as x goes to 6 of the square root of x plus 3 all plus 3 over x minus 6. I check it and I get a 0 over 0, and I know I can use a L'Hopital's rule. I can write it many different ways. I think the easiest way to write it is with parenthesis and a prime. Right? So I'm saying I know I can use L'Hopital's rule here. As soon as I'm doing a limit and I get a 0 over 0, I can use L'Hopital's rule. What does that mean? How am I going to write it to my audience? I'm going to show you that I'm doing a derivative of the numerator and a derivative of the denominator. So we already talked about the derivative of the numerator. What is it? Yeah, 1 over 2 square roots of x plus 3, and the derivative of the denominator is just 1. Nice. So I've done L'Hopital's rule. I can simplify, and I would probably prefer that you do. Of course, this just becomes 1 over 2 square roots of x plus 3. And then, of course, I can evaluate 1 over 2 square roots of 6 plus 3. So it's still 1 over 6. What do you know? It better come out the same. Right? It had better come out the same. I think we did this one yesterday, but let's do it again. Let's see. The limit as x goes to 0 of cos of x minus 1 all over x. Sorry, lost my mind for a second. So this one is kind of interesting to do with a conjugate as well. Let's see if we can do that first. Let's see what happens. Limit as x goes to 0 of star, and star is cos of x minus 1 over x. And so we're going to use a conjugate here. So what's my conjugate? That's right. So cos of x plus 1 over itself, because I have to multiply by 1, right? I got to multiply by something over itself. What happens upstairs? What happens upstairs? I get a cos x minus 1, right? Cos squared x minus 1, yes? What is that, though? You recognize it? Negative sine squared, yeah. Negative sine squared. Oops, sorry. I made a mistake here. This is cos of x, right? And so I can kind of see this guy becoming what I want, a negative, a sine x over x, sine x over cos x plus 1. Why am I doing it that way? Because I know something about sine x over x, right? So the limit as x goes to 0 of star is minus the limit of sine x over x times the limit of sine x over cos x plus 1. So what's that middle piece? Is 1, right? Yeah, yep. So negative 1, and then the other one I can evaluate. Oh, that's cos x goes to 0. That's sine of 0 over cos of 0 plus 1. So final answer is 0. So this piece I just evaluated. Sine of 0, which is 0. Cos of 0 is 1, so 1 plus 1 is 2. Right, so there I got the 0 over 2. Same problem, but now with L'Hopital's, right? Same problem, but with L'Hopital's. So the limit as x goes to 0 of cos of x minus 1 all over x. I plug in right away and I get a 0 over 0. So I know I can use L'Hopital's rule. I'm just doing it a different way this time. You can do what you want. I'm telling you I'm about to apply L'Hopital's rule. Right? And what do I get upstairs? Nice. And downstairs? 1. And that can just be evaluated, which is negative sine of 0, which of course is 0. Yeah, question, Ethan. Yes, but I at the end. Oh yeah, cos of 0 is 1. From yeah, yeah.
In the denominator, when you have x times cosine of x plus 1.
Yep.
Distribute the x.
You can, but you can, but we don't want to usually. We want to keep things factored. And remember, we're looking for the piece that we know, right? We know that limit. When I say cosine or sine, I'm instantly thinking of their curves all the time. So there's my cosine curve. So clear, you can see it starts at 1, and my sine curve, right, starts at 0. So yeah, I'm always whenever I see a sine or cosine, I'm drawing that graph in my head for sure. Better on the paper, of course, or in Desmos. Nice. So L'Hopital's rule, not bad, right? Am I right? It's easy, yes? You have to practice. You have to practice. So I did record that today. I didn't record the lecture yesterday with the proof and all of that, but you know, life goes on. It happens sometimes. Remind me though in the future if I forget. Good. We're ready for new material. Yes? It's a freight train. It's going downhill. It never stops. And it just keeps going and going and going. So you have to keep up with me. What did I say? If you're not up to date with me by the chain rule, you're in trouble. So what is today, Wednesday? I should do the chain rule tomorrow. So you need to be confident with everything up until what we've learned so far, especially what we're doing today as well. So you've got to be practicing. Here we go, product rule. So I'll say if y equals f of x times g of x, or y equals f of x divided by g of x, right? I'm going to talk about f, its derivative, g, and its derivative. Same thing over here, f, its derivative, g, and its derivative. Product rule, I'm going to do a loop like this. Quotient rule, I'm going to do a loop like this. And so right away, can you see the letters? Can you see the letter P and the letter Q? Yeah. So product rule is fg prime plus gf prime. So you can see I'm doing this product plus this product. And a plus in between. Morning. Quotient rule, you see I'm starting at a different place, right? Do you see it? On the product rule, I started at f down to the diagonal to g prime. On this one, I'm starting at g down to f prime. There's a prime there, sorry. Minus fg prime all over g squared. I will prove the product rule to you today. If you are interested, if you're a math major, none of you, or a physicist, one of you, you probably want to do the proof, the other one on your own. So how can I tell when to use the product rule? I got to have I got to be multiplying two functions together. And when do I use the quotient rule? When I'm dividing two functions, right? Of course, the derivatives must exist, okay? Now, you'll see me do a couple here, and you'll see me write out the loop. Eventually, you need to lose the loop that I'm showing you. When you're in Calc 2, you have to be able to do product rule and quotient rule quickly. So let's do, yes. Okay, I'll wait. Yeah, Ethan. Yes. So yeah, product rule, quotient rule. So I want to start with a product rule that I don't need to use the rule with. And then I'll use the rule and show you that it gives me the same result, right? So product rule examples. So for example, let's start with x squared. And of course, we already know that y prime gives us 2x. So it didn't need a product rule. I could just do this derivative by shorthand. But if I look at it, x times x, that's x squared. My first function is x. The derivative of that is 1. The second function is x. The derivative of that is 1. And I'm doing a product rule, so I get y prime is x times 1 plus x times 1. So 2x. Same answer, of course. Where did what come from?
One.
So remember, I find the first function and its derivative, right? So the slope of y equals 1x is 1. Yeah? Ethan?
Product rule only used to find the difference.
Yes. Let's do another one where I don't need no. Oh yeah, let's do another one where I don't need the product rule. Okay, so y equals x plus 2 times x squared minus 1. Polynomials, right? So I know I can do shortcuts here if I can just get this to be a single polynomial, which is what? X cubed plus 2x squared minus x minus 2, right? Will you double check me there, please? Yes? And so y prime, very simple, is what? 3x squared plus 4x minus 1. Agreed? Yeah, nice. Same problem with the product rule, right? Same problem with the product rule. What's my first function? Nice, x plus 2. What's its derivative? 1. Second function in the product is x squared minus 1. And what's that derivative? 2x. And we're using this loop. So I get y prime is 2x times x plus 2 plus 1 times x squared minus 1. So it looks like I get 3x squared plus 4x minus 1. Same answer. Of course. Of course, same answer. Okay, not too bad, right? Good, let's do one where we have to use the product rule now. So for example, y equals e to the 2x. Anybody know this answer from yesterday when I talked about the chain rule, or if you even remembered the chain rule? Anybody know this? Yep. 2e to the 2x. So notice that the inside function is 2x, right? Everyone agree with that? Where I put the input, where I put the money in the soda machine is up in is the exponent, right? For e to the x. So e to the 2x, the derivative of that inside function is 2. So that's where that outside 2 is coming from. And then why do I have an e to the x again? Because the derivative of e to the x is e to the x, right? Okay, but let's write this as, oops, this guy is e to the x times e to the x. Do you agree with that? Yes? Yep. Good. So first function is e to the x. Derivative is what? Yep. Second, derivative, f prime, right? Second function g is also e to the x. Derivative is e to the x. And I'm doing this loop. So I get y prime is e to the x times e to the x plus e to the x times e to the x. Looks like I have two of them. right? Which of course is e to the 2x. Or better yet, I'll do it this way first. E to the x plus x, right? Which is e to the 2x. Same answer. How we doing? We're okay? Another one where I need to use the product rule. Oh, this one I didn't actually need to use the product rule, but I don't know the chain rule yet. Ethan? Yeah. Yeah, but look at the difference there. When the base is a variable and the exponent is a power, I use the power rule. But when the base is a number and the exponent is the variable, I have to use a different rule. And we're almost ready for that rule, chain rule. Okay, so but for now we just know if y is e to the x, y prime is e to the x. All right, here comes another one where we must use the product rule. So let's say y equals square root of x times e to the x. And this is one, and you'll see in the homework, where you'll get an answer, but it's not what the book has. And basically, the idea is you want a single fraction, every time, a single fraction, completely factored numerator, completely factored denominator, okay? So first function is square root of x. What's the derivative? Yeah, 1 over 2 square roots of x, right? Second function is e to the x. What's the derivative? Yep. Product. So y prime is square root of x times e to the x. Everybody see where I'm getting that? Right? Plus e to the x over 2 square roots of x. So there's my answer. I look in the book and it's not what I want. Because obviously you see I have two fractions here, right? Everything's a fraction, right? Every single term is a fraction over 1, right? So on this one I need to get an LCD. So my LCD is 2 square roots of x. Okay, you agree with what's happening here? I need to get the same denominator in both fractions, right? The fraction on the right already has a denominator, so I just use that as my LCD. Everyone agreeing? So now what do I have? I have 2x e to the x plus e to the x all over 2 square roots of x. Double check me, please. Make sure you agree with me. Yep, square root of x times square root of x. So that's x to the 1/2 times x to the 1/2. So that's x to the 1/2 plus 1/2. So that's x to the 1, so it's x. Right? I look in the book, it's still not what I have. And I realize, oh, I can factor. So there's my final y prime. I've got e to the x times 2x plus 1 all over 2 square roots of x. Let's do a tangent line there. So Desmos. Yes, sure. Sorry about that. What's that? Say again?
You didn't bring up the feedback.
Yes and no. The reason, and you'll see in chapter 4, we if we have everything factored, it's easy for us to find critical numbers. So then the critical number for the numerator here is minus 1/2. The critical number for the denominator is 0. If you notice, both of those numbers will make the numerator 0, right? The minus 1/2 will make the numerator 0. The 0 will make the denominator 0. Okay? So by factoring it, I can see those numbers quicker. So eventually we're going to have to factor it anyway, so let's just start factoring now. In the first one, I don't see minus 1/2 that clearly. I don't see that minus 1/2 is clearly makes the top stair 0. But here I do. Go.
Factored.
Say again?
We get penalized if we don't fully simplify.
I'd rather it factored. So I'll decide on at the moment. Yeah. Let's do a tangent line there, right? So we have our original function, y equals square root of x times e to the x. And we know our derivative, but let's pick a point here. How about 1 comma e? Make it easy, right? So I picked anything I wanted in the domain, right? You with me? When I'm doing a tangent line, I can pick any x value that's in the domain. And I plug it in to get the y value, right? Everyone agree with 1 comma e? Yeah? Yes, it is. Yep, thanks. So if I'm looking at my derivative, right? So I have 1 comma e as my point, right? And my slope is what? E to the 1 times 2 times 1 plus 1 all over 2 square roots of 1. So 3e over 2. Double check me, please. So tangent line is what? Y minus what? Yep, y minus e equals 3e over 2 times x minus 1. Everybody with me? So y minus e equals 3e over 2 times x minus 3e over 2. And I'm going to add e. And obviously I need a 2 downstairs, so I'm going to multiply by 2 over 2. So final answer, y equals 3e over 2 times x minus e over 2. Oops, e over 2, right? You agree? Yes, Ethan. I'm allowed to, this is why I like doing math. I can pick anything I want in the domain. I picked 1. Why did I pick 1? I would have picked 1 or 4. Why would I pick 1 or 4? Look at my function. Right? I want a nice square root, right? So, and look at my derivative. I again have a square root in it. So I want to put some nice number in there. So I picked the 1. The function gave me e. When I plugged the 1 into the original function, square root of 1 times e to the 1 is e. Yep. Good, let's check this. So y equals 3e over 2 times x minus e over 2. Oop, minus e over 2. Boom. Yeah, you okay? Question? No? Yeah, yeah. Yeah, so I had already picked one, found E, I found my derivative, and how did I get the slope? I plugged one into the derivative. Nope. So M equals F prime of 1, right? Now, there's a nice way to check your derivatives if you have them right or not on Desmos. So let me just show that real quick. We okay here? Okay. Tell me when.
Um, 3E is the slope.
3e over 2 is the slope, yeah. Michael? Yes?
I'm still right.
Okay.
I think I can
I'll wait. Nice. So there's a nice way to check derivatives here, and that is to take my original function and ddx it, right? ddx gives me my derivative, okay? And then what I want to do is also plot my actual derivative that I got, which was e to the x times 2x plus 1 divided by 2 square roots of x. And you see what happened is my graph turned red. So if I turn the derivative off and just show the Desmos doing the derivative, I get an exact match. Right? So a nice way to double check that you have your derivative correct. What not to do is if you have your derivative wrong, right? Imagine I have this, right? Right? You can clearly see they're different now, yes? But you can't panic. That's the key, right? If you're in a plane and it starts to crash, you cannot panic, right? I mean, I'm probably gonna just start praying, but and I swear to God, I'm an atheist. Isn't that fun? Is that funny? It's funny, right? How can you swear to God if you're an atheist, right? So, what do you do? What do you do when you get something wrong? You're more than welcome to look at your work and see if you can see it, Most likely you won't. Better thing to do is brand new piece of paper, do it over, right? Let's do another one. What about y equals sine of 2x? Well, this is a chain rule problem. Chain rule problem says, hey, look at the inside function. Is the inside function have a slope different than 1? It does. It has a slope of 2. So that's hinting that I use a chain rule. In fact, you'll see we're going to always use the chain rule. We're not going to always use the product rule, only when we have a product. Question, Ethan? Interior function has a slope different than 1. Well, you do, but you just don't know you're doing it. Yeah. So y prime here, what's the outside function? Is a sine function. What's the derivative of a sine function? Cosine function. I want to keep the cat in the box. Keep what's inside, and now multiply by the derivative of the inside, which is 2. Okay, let's do this one with product rule. So sine 2x is what? The identity, trig identity. Sine of 2x is what? Yep, keep going. Nice. So product rule. First function is 2 sine x. Derivative. Two cos x, yes. Constants go for coefficients go for the right. Yep. And second function is cos x. What's the derivative? Negative sine x. Good. We're doing a product rule. So my y prime is negative 2 sine squared x, right? You agree with me there? Plus 2 cos squared x. I can factor out a 2, and I get cos squared x minus sine squared x. That one should be memorized as well. What's that identity? Cosine 2x, very good. Same answer. Let's do a tangent line there. What do you want to pick for your x? Okay, sorry. Where are you?
I'm still getting to that.
You're on line 3? Question? Well, wait a minute. Where are you? Line 1, yeah? Yeah. I can. I know this is a trig identity that gives me a product of two functions instead of just a single trig function. Sine is not a sin is not a function. I need an angle. It's got to be sine of theta, right? I can't. It's not a sin, right? It's not. I'm not multiplying sin times 2x. It's sine of 2x. Question? Yeah. Say again? No, I just switched the order, right? I factored out a 2, so I still have 2 cos squared, right? You see it? I just switched the order, right? If you see I multiply, I get that. I multiply, I get that, right? But this is the identity I have memorized from pre-cal that all of you have memorized. If you don't have memorized, put it on your damn formula sheet or get the tattoo, right? One or the other. One of the all three. Let's do a tangent line here. What x value do you want to pick? Two? Not two. What? Four? No. What? Pi is okay, but it's kind of boring. Give me a different one. Pi over 2? Sure. That's kind of boring too, but... Right? Because if I look at sine, right? At pi, it's 0, right? At 2 pi, I'm trying to pick a point where it's not too boring, but pi over 2 is fine. Pi over 3 is better. Thank you. We want a 3 or a 4 downstairs, right? So I have to find a y value. How do I find that? Yeah, plug it into the original function. Sine of 2 times pi over 3. That's the same as sine of pi. That's positive sine of pi over 3, which is square root of 3 over 2. And I have to find the slope. I have 2 times the cosine of 2 times pi over 3. Everybody with me? So 2 times cos of 2 pi over 3. That's negative 2 times the cosine of pi over 3. And cos of pi over 3 is 1/2. So negative 1. This is not a trig class. You all should have taken trig. If you haven't, you're in trouble. Take the trig class on, what's his name? Khan Academy. Free, about 8 hours of work. All right, we're ready? Yeah. Yeah. It's negative cos of pi over 3. Oh, okay. Here, this. Yeah. Yeah, it's positive sine of pi over 3. So I'll show you how I think about trig. Pi over 3 means cut pi into 3 or the whole circle into 6. And it's one of these bow tie pieces. There's my 1 pi over 3. There's my 2 pi over 3. There's my 3 pi over 3 here, 4 pi over 3, or 5 pi over 3. It's one of those. I know it's 2 pi over 3, and sine is a height. Okay? And that height is up. So that's where I get the positive from, and now I just have to think of my reference table. Yeah. When I did the slope, I got 2 pi over 3, but cosine is an x. So that's negative that way. Right? So that's why I know the answer is going to be negative, and now I just have to find cos of pi over 3. Yeah. No, that's good. But I teach trig way different than most people. So like most of you probably use the unit circle. I don't use that. I think that's nonsense. But it's fine if you use it. Evan, you okay? Yeah? All right, let's take a look at our tangent line now. I had y equals sine of 2x, right? And we found the point pi over 3, comma, I forget already, was it negative square root of 3 over 2? We just decided. We picked something in the domain. Yeah. I get, what, square root of 3 over 2? Nice. I'm happy to see it hit the curve, right? I'm happy to see my slope was negative, right? Because I can picture that tangent line on there, right? And I got y equals negative x. I forget already. Oh, I didn't do it. So y minus pi over 3. Oops, sorry. Help me. Yeah, square root of 3 over 2 equals negative 1 times x minus pi over 3. None of you are. I'm doing all the work. You're not even copying me now. When I'm saying when I'm writing, you should be racing me, right? So I'm going to my Desmos 2 pi plus 3 square roots of 3 all divided by 6. Boom. Ha! Love it. What's the issue with the trig with everyone? What's the issue? Why does the trig bother some of you? Just didn't memorize it? Yeah. Yeah, the Khan Academy would be good. I'm sure you could do it in a couple of days. Good. What up? What's up with the trig? Mike, what's up with the trig?
They, I don't know. I just forgot most of it.
You forgot all of it, most of it?
Yeah. Most of the time I just looked at it and just
Yeah.
so all
You put that unit circle on your formula sheet, right?
and last time.
Good. All right, let's do some quotient rule. Well, let's take a little break.